The LTE network consists of an access part, EUTRAN, Evolved Universal Terrestrial Radio Access Network, and a core part, EPC, Evolved Packet Core. Together they form EPS, Evolved Packet System. In the access there is only one node, the eNode B, Evolved Node B, without any separate control node. The advantage is that the TTI, transmission time interval, is short and the access becomes very flexible and fast during handover. New radio spectrum cannot be invented, only utilized more efficiently. In LTE there is a new access technology called OFDMA, Orthogonal Frequency Division Multiple Access, which is more efficient technique compared to CDMA used in UMTS. OFDM is a special case of FDM, where the carriers are made orthogonal with the help of a Fourier transform. This leads to that the subcarriers can be put very tight together. The core consists of two routers, thus as in the previous network GPRS and UMTS. One router is looking towards the outside world, the PDN gateway, Packet Data Network Gateway. The other one is focusing on the access, MME/SGV, Mobility Management Entity Serving Gateway. This last router is split into two parts. MME is only involved in the control plane, and the main function for the serving gateway is transporting user plane IP packets. Before following a mobile during an attach procedure, let's take a look at the identities of the UV. Every UV has a unique, permanent identity of its SIM card, the IMSI, International Mobile Subscriber Identity. The IMSI is also permanently stored in the HSS, Home Subscriber Service, in the home network. Already from the start in GSM, there has been a high focus on security within the 3GPP technologies. When the mobile is communicating with the network, the IMSI is used as little as possible. Instead, an alias is used called the temporary IMSI. This temporary ID is allocated by the MME during the attach procedure. The UV needs to be identified on the radio. That ID is called the Radio Network Temporary ID. Since the access consists of only one node, it has to be the eNode B that is handing it out. An RNTI will be handed out every time the UV establishes radio contact with an eNode B. Now the UV has an ID towards its operator, towards the core, and it is identified on the access, the radio. But there is still one identity missing, the IP address, which is allocated by the PDN gateway as soon as the UV is powered on. In the previous IP-based networks, GPRS and UMTS, the IP address was handed out when the user wanted to set up the service and taken back when the service ended. So why has that been changed in LTE? Well, LTE is a purely IP-based network. Both real-time and datacom services will be carried by the IP protocol. If the mobile doesn't have an IP address, it cannot be reached by incoming sessions, like a VoIP call. In GPRS and UMTS, you could still reach the mobiles with an incoming call over the circuit-switched core. As an end user, you can specify from which IP address sphere the desired IP address should be fetched from. This parameter is called APN, Access Point Name. When the mobile wants to attach the network, it will contact the base station it hears the strongest. That eNode B will then select an MME for the UE. The MME will, on the other hand, select a serving gateway and a PDN gateway. The PDN gateway is selected from the APN parameter provided by the end user or his operator. During the attached procedure, the UE will be allocated an IP address from the desired PDN gateway. Now the UE is attached. So, now let's take a look on the user plane. When an IP packet carrying user data reaches the PDN gateway, the network will start to tunnel the packet. The reason for tunneling is to make the handover more efficient from a routing perspective. Tunneling means putting an IP header in front of the original IP packet. Every node in an IP-based network has its own IP address. Let's call it an internal IP address. When an IP packet arrives from the outside world, the mobile network will put an extra IP header in front of the packet with the internal IP addresses. In this first case, the internal IP address of the PDN gateway and serving gateway. When we reach the serving gateway, the outer IP header will be removed and a new one added, with the address of the serving gateway and the eNode B. When an end user moves around in a network, a handover is required. In LTE, it is the base station that takes the handover decision based on measurement reports from the UE. The old eNode B will contact the selected eNode B and send over UE content. The UE content holds, amongst other parameters, the information of the attached MME. The new eNode B will update the MME that it is from now on the responsible eNode B. The MME will then contact the serving gateway with the internal IP address of the new eNode B. So the user IP packets can be rerouted towards the new eNode B by changing the IP address in the outer IP header.